This is Lab 3 Black Hole Orbit. The purpose of the lab was to obtain motion data from a star using a CSV reader in VPython to determine the mass of a black hole. Some other concepts in the lab were the momentum principle and gravitational force. After the experimental code was run, the mass of the black hole was determined to be 3.98 times 10 to the 31 kilograms. Two main principles that are important to this lab are the momentum principle and Newton's law of gravitational motion. The change in momentum, dp dt, is equivalent to the net force acting on an object times the duration of the interaction. Newton's law of gravitational motion describes the attractive force between masses with the following equation, and the constant g is equal to 6.67 times 10 to the negative 11 Newton meters squared times kilograms to the negative 2. The code was instantiated with the following information. The mass of the star is 1.98 times 10 to the 30 kilograms. The time step, which was the number of seconds in a day, is set to be 86,400 seconds. And finally, the position of the black hole is -4 times 10 to the 10, 5 times 10 to the 10, 0 meters. The code reads through the specific CSV file stardata.csv 2 columns at a time as specified. The first while loop in the code is to compute the x and y components of velocity for how the star moves around the black hole. The second while loop iterates over the entirety of the data values in the .csv file. The initial and final momentums are calculated by the lines indicating v init and v final. The initial and final velocities using the momentum principle at p equals m delta v. Delta v and delta p are obviously the final minus initial values of each respectively. dp dt is equal to the change in momentum over the change in time. This is in derivative notation. F net is equal to dp dt according to the momentum principle. P hat is given by the initial momentum divided by the magnitude of the initial momentum, which is the unit vector used for scaling future variables. The magnitude of dp dt parallel is the magnitude of the final momentum minus the magnitude of the initial momentum divided by delta t. dp dt parallel is given by the magnitude of dp dt times p hat, placing it in vector form. And as per the logic used earlier, f net parallel is equal to dp dt parallel. dp dt perpendicular is given by dp dt minus dp dt parallel because when the parallel and perpendicular components are summed, they give dp dt. And at the same as earlier, again, f net perpendicular is equal to dp dt perpendicular. The arrow scale is set to be 3.5 times 10 to the negative 16, which determines how long to draw the arrows to represent the vectors logically. In order to find the mass of the black hole, the following line of code is inputted. Blackhole.m equals magnitude of f net times magnitude of the star position minus the black hole position squared divided by g times star mass. This is from Newton's law of universal gravitation, with g as the same constant as stated earlier. When the code is run, the black dot is the black hole, the green trajectory is that of the star, the yellow arrow is the total net force, the blue arrow is the perpendicular force, and the black arrow is the parallel force. Here is the mass of the black hole by calculated in the code, which is shown in the shell of Python. The mass of the black hole is 3.98029 times 10 to the 31 kilograms. What does it mean? dp dt can be calculated from the observed position data, while F net is the force that is causing the observed motion because it isn't something that can be measured directly. F net is qualitative, while dp dt is quantitative. This follows through for dp dt parallel, F net parallel, dp dt perpendicular, and F net perpendicular. If the black hole whose mass was found was removed and a different black hole was placed in the same location, assuming the motion of the observed star remains unchanged and is affected only by the gravitational force of the new black hole, could you tell the difference? Since everything is in relation to the star, which is not changing, meaning F net, the magnitude of r squared, the mass of the star, and the constant g would all be the same, therefore the mass of the black hole would be too the same. This concludes Lab 3 black hole data. Motion data was obtained from a star using a CSV reader in VPython using two main physics principles, the momentum principle and Newton's law of gravitational motion. With these, the mass of the black hole was determined to be 3.98 times 10 to the 31 kilograms. Thank you for watching.